Hello and welcome to today's class. For this class, what's the concept of gas law? So let's discuss chemistry. Let's discuss gas law a bit. Before we start with gas law, let's look at the concept of kinetic molecular theory of matter. So very please, let's look at kinetic molecular theory of matter. Let's start with this, please. Before we start with gas law, let's look at kinetic molecular theory of matter. Are we there? Put down, please. Put down. We know that matter is made up of tiny particles. We know that matter is made up of tiny particles. Are you there? Tiny particles which include atom, molecule, and ion. We know that atom is made up of tiny particles which includes atom, ions, and molecule. Or if you want to, atom, molecule, ion. Full stop, please. Put down, please, a paragraph. New paragraph, please. The kinetic theory of matter states that the kinetic molecular theory of matter states that are we there? Matter is made up of tiny particles. Matter is made up of what? Tiny particle, comma. Are you there? This tiny particle moves in constant random motion. This tiny particle moves in constant random motion. Are we there? This tiny particle moves in what? Constant random motion. Are we there? Yes. Colliding with one another, thereby possesses kinetic energy. Kinetic energy. Are we there? Yeah. Thereby possesses what there? Kinetic energy. Now, a paragraph, please. The behavior of gases can be determined. By some factor which include pressure, that's your P. Number 2 there, volume, that's your V. And number 3 there is called the temperature, that's capital T. So I said the behavior of a gas can be determined by some factor which include what there? Pressure, volume, and what there? And temperature. Are we there? Put down. This implies that the behavior of any gas can be determined. This implies that the behavior of any gas can be determined. Are you there? By its pressure, comma, volume, and temperature. This implies that the behavior of any gas can be determined by its pressure, comma, volume, and temperature. Are we there? Full stop. Any scientist, yes, what you're having here, same thing. So are you there? Any scientist propose law which govern these parameters. Any scientist propose law which govern these parameters Are you there? Comma. This law include number one. This law include number one. Number one, Boyle's law. Number one, Boyle's law. Let's start this place. Number one is what there? Boyle's law. Put down, please. Are you there? Yes. Boyle's law states that are you there? The volume of a given mass of a gas, is inversely proportional to its of a gas. The volume of a given mass of a gas, are you there? Is inversely proportional to its pressure. Are we there? Provided that temperature is kept constant. Are we there? Hold on, look up. When it comes to Boyle's law, the idea is on one thing. Whenever I hear the word temperature is kept constant, I'm talking of what? Boyle's law. Now go back to what I gave you. It states that the volume of a given mass of a gas, is what? Inversely proportional to its what? The pressure. Hold on, please. From here, mathematically, observe. We said that Boyle's law, right? It said what? The volume of a given mass of a gas, so the volume is what? Inversely 1 over what? Pressure, Inversely. The way you represent inverse proportionality is what? Use what? 1 over that stuff. Are you there? So inverse proportional to what there? To its pressure. Provided that what? Temperature is what there? Kept constant. So the concept that when temperature is kept constant, we talk about what there? Boyle's law. Apply mathematics here. What do we know? This becomes what there? V. How do I take off this sign? Into what? Equal to what? And a K, right? Dot what? 1 over P. To take off proportionality sign, introduce an equal to and a K. K is constant. All I have here, this becomes V equal to what? K times 1 is what? Is K over what? Over P. Now, what is now the constant of Boyle's law? Look up. Over 1 here, K times 1 is what? K equal to what? VP. This is relationship between Boyle's law, please. Relationship of Boyle's law. This is said to be the relationship of what? Of Boyle's law. Are we there? Under this, please. Note, please. Under this note. Note, please. Are we there? Under this note, please. Are we there? If the temperature is kept constant, Boyle's law can also be expressed as Boyle's law can also be expressed as P1 V1 equal to what? P2 V2, please. If temperature is kept constant, Boyle's law can also be expressed as what? P1 V1 equal to what there? P2 V2. Let's define parameters. Where V1 is what? Volume at pressure 1. V2 is what? Volume at what? Pressure 2. Please. These are like the definition, please. Volume at water at pressure 2. So when it comes to Boyle's law, the idea is that temperature is what? Kept constant. Aside that, it's given as what? Just formula there. P1 V1 equal to what there? P2 V2. I said V1 is what? Volume at pressure 1. While V2 is what? Volume at what there? At pressure 2. Alright. Having said this, Now, before I proceed with solving problems and etc., let me emphasize something, please. Now we said in this thing we have volume and pressure, Abi. Let's start with volume. Let's say for volume. Volume, for instance, what are the several units of volume? We have what there? Centimeter cube, Abi. We have meter cube, Abi. We have decimeter cube. What's over there? Liters, right? We have what there? Liters. True? Yeah. For volume can be expressed in terms of what? Centimeter cube or meter cube or decimeter cube or what there? Or liter. Note this relationship, please. Note that 1 meter cube equal to what? 1000 what? Liter. Note that 1 meter cube equal to what there? 1000 liter. That's for volume. We have picked volume and its several units and how to convert. 1 liter is what? 1000 what there? Liter. So the several units of volume include what? Centimeter cube, meter cube, decimeter cube, and what? Liters. What of pressure? What are the units of pressure? We have what there? Newton per meter squared. We have what? Pascal. We have what there? Atmosphere, ATM. We have what there? We have bar. These are several units of what? Of pressure. We have pressure in terms of what? Newton per meter squared. In terms of what? Pascal. In terms of what? ATM, atmosphere. In terms of what? In terms of bar. Now hold on, look up. Let me give you for conversion's sake. Note that 1 Newton per meter squared is equal to what there? 1 Pascal. Are you there? 1 Pascal, please. Very important. Note that 1 per meter squared is equal to what there? 1 Pascal. Are we there? Very important, please. Are we there? Aside this one, look up. Aside this one, note that 1 ATM equal to what? 101.325 Newton per meter squared, right? So at STP, look up, at STP, what's STP? Standard temperature and pressure. Are you there? At STP, atmosphere equal to what there? 101.325. Aside, look up, we still have what? Hg now, mercury. Millimeter what? Millimeter what? Mercury. That's also pressure too, right? So are you there? Also that at STP, mercury is given as what? 760 millimeter what there? Mercury. At STP, pressure is what? 760 what there? Millimeter what? Mercury. In terms of millimeter mercury is 750. In terms of what? ATM is what? 101.325 Newton per meter squared. Are you there? Also note that 1 bar is what? 10 to the power what? 5 Newton per meter squared. Note this relationship and how this stuff works. They are very important in conversion sake. Please note how these stuffs work, please. Note how this stuff work, please. So I have volume and its SI units, and this one in case of conversion we have pressure and its several units and also the conversion values there. Are you there? So this is what we have here. Let's take a question and let's see what we get, please. Example 1, please. Example 1. Example 1. Let's start with example 1, please. It says a gas contained in a flask of 500 milliliter ml. So also know that volume is also what? In what? Milliliter. Yes, milliliter. Says a gas contained in a flask of 500 ml. Are you there? Capacity was allowed to expand into another flask. Hold on, look up, hold on. Listen, they said a gas contained in a flask of what? 500 milliliter was allowed to expand. Now look up. If it expand, without value to which it will be expanding, will it be small or bigger? Bigger. So it's that value that's coming up now should what be a bigger value, because what is expanding. Oh, it says put down. It says come in.
To expand.
Hold on. Is allowed to expand into another flask of volume 600 milliliter ml. Are you there? Comma, connected
Volume.
of volume 600 milliliter, comma, connected through a valve, valve. Are you there? Connected to a what? A valve, and at the same temperature. Get the word at the same what? It means what? It's kept what? Constant. Temperature is kept what there? That's what? Your Boyle's law. Put down please. It says at the same what? Temperature. Full stop. If the final pressure of the gas is 1.01 times 10 to the power 5 times 10 to the power 5 Pascal Pa. If the final pressure of the gas is 1.01 times 10 to the power what? 5 Pascal. Are we there? Are we there?
Yes.
Comma. When the valve is open, when the valve is what? Open. Are you there? What was the pressure of the gas in the 500 milliliter flask? What was the pressure in the flask? What was the pressure of the gas in what? 500 what? Milliliter. Are you there? I said, when the valve is open, what was the pressure in the gas in the 500 milliliter flask? Are you there? Are you there? Full stop. Listen, hold on. It said that when the valve is open, Abi, now say that what was the pressure in the gas in the 500 milliliter? That pressure I'm looking for. You say, what was the pressure, Abi? So I'm looking for pressure, Abi. Is it P1 or P2? Why is it P2? Why is it P2? Hold on. Let's please. Hold on, please. It says the volume of the valve is negligible. Put on, please. It says finally, the volume of the valve is negligible. First, your first task is what? Let's start what? Give us Abi. It says that a gas contained the flask of what? 500 what there? Milliliter Abi. That's my first volume. That's my what? My V1. Abi. So V1 is what? 500 what there? Milliliter Abi. Capacity was allowed to expand into another flask of what? That's my V2. Abi. That's what? V2 is what? 600 what? Milliliter. No problem. Connected through a valve, Abi, at the same temperature. It means that temperature is what? Kept constant. So I'm using what there? Boyle's law concept. Hold on. It that says what? Connected through a valve, Abi, at the same temperature. Okay. If the final pressure of the gas, please, that final pressure, is it P1 or P2?
P1.
Listen, I know what final pressure.
P2.
Is it P1 or P2? P2 now. Even hold on. Let's say the word final is not there. Let's assume they said that the pressure of the gas is 1.01 to the power 5, right? How will you know if it's final or if it's final? Here's the thing. They said when the valve is open, what is the pressure of the gas at what? In the what? 500. I'm looking for the pressure in 500. That's what? P1. So hence what I'm giving is what? P2. Let's say they didn't give us final pressure in that question. Final pressure, let's assume that is P2 or B. Let's say they didn't mention final pressure there. We already know that I'm looking for pressure at what? 500 what there? Milliliter. That's what? Pressure at P1. So in essence there, I'm giving final pressure as what? P2 as what? 5, no, as what? 1.01 10 to the power what? 5 what there? Pascal. Are you there?
Yes.
Pascal. Is that all? What are you looking for? Find what? P1 is unknown now.
Yes.
So here's the thing now. From Boyle's law, from what?
Boyle's law, P1 equals to P2 V2.
I'm coming. Boyle's law, B.
Yeah.
P1, B1, what the what there? P2, V2. Are we there?
Yeah.
What are you looking for? P1, Abi.
Yeah.
So make P1 subject. Divide by what? V1, V1, Abi.
Yes.
What do we get here? This cancel this, Abi. So it means P1, what the what there? P2, V2 over what? V1, Abi. So P1 now is equal to what? What's the P2?
1.1.
Hold on. Are we converting?
Yes. We are not converting.
No, because it's a meter. No problem. So let's put then. What's P2? 1.01 times 10 to the power what? 10 to the power 5. What's the V2? 600. V2 600 over what of V1? 500. What's your P1 here? If I multiply, what do I have there? What do you have if I multiply? What do you have here? Let me have it. It says if I have 1.01 times 10 to the power 5 times 600 divided by 500, I have 121. So 121 200. Please, what's my unit here? Pressure. The pressure here is given as what? Pascal here. What's my unit here? Pascal. Are you there? Now hold on, look up. My pressure was, look up, here in the question was given as 1.01 Abi. So I can convert it to decimal. So that becomes what there? P1 is what? 1.21 Abi. 10 to the power what? Observe. 1, 2, 3, 4, 5. Yes. 10 to the power what? 5 what? Pascal. So this, you can leave it this way or this way. It's still very much correct, right? So you have that. Lesson number 2, please. Example 2. Example 2. Let's do example 2 under Boyle's law. Are you there?
Yes.
It says that on the 100 meter cube of gas has a pressure of 1 atmosphere. 100 centimeter cube of a gas has a pressure of 1 atmosphere. Are you there? Determine the volume of the pressure at 5 atm, the atmosphere, sorry. Determine the volume of the gas at 5 atm. Are you there? Keeping the temperature constant. Please, if I keep temperature constant, what's the concept there? Boyle's law, Abi. First, let's list out the givens, please. In the question says that 10 meter cube of gas, that's your first volume, Abi. That's V1, Abi. V1 is what? 100 meter cube. Yes, centimeter cube of gas, no problem. Gas has a pressure of what?
1 atmosphere.
That's your P1.
Yes.
That's P1 is what? 1 what? ATM. Atmosphere, short form, ATM. Are we there?
Yes.
Determine the volume of the gas. That's your V2 is unknown. So V2 is what? Unknown. What next there? at 5 atm. That's your P2. That's your P2 is what? 5 atm. Are we there? Keep the temperature constant. If I keep temperature constant, what's the concept there? Boyle's law. So I'm using what here? Boyle's law here. So I will recall from Boyle's law that P1 V1 equal to what there? P2 V2. All I make subject here, I'll make V2 subject. I'll look for V2, Abby. Come here, what's V2? I'll divide by V2. That becomes P1 V1 over V2, sorry, P2 per se. I'm looking for V2, divided by P2 now. Equal to what there? P2 V2 over what? P2. This cancel this. What's V2? V2 is what? P1 V1 over what there? P2. What's your P1? Check. 1 now. P1 now is 1 atm times what of V1? 100, right, over what of P2? 5, right? I'll have 100 is what? 100 over 5. All I have here, V2 is equal to what there? 20. 20 what?
20 atm.
Volume is atm, Abi.
Centimeter cube.
Centimeter one there, cube. So this is my answer, please. Volume is not atm. Oh. Pressure is atm. Oh. Atmosphere, please. So volume is what? 20 centimeter cube. These are solve problems under Boyle's law. Let's do yet another example. Let's do yet another example here. Are we there? Are we there? Are you there? 375 cm cube. 375 cm cube of a gas. 375 cm cube of a gas has a pressure of 770 millimeter mercury, mmHg, right? Hi there. Find the volume if the pressure is reduced to 750 millimeter mercury. I said 375 centimeter cube of a gas has a pressure of what? 770 millimeter mercury. Are you there? Find the volume if the pressure is reduced to what? 750 millimeter mercury. Let's get them, please. Solution. What's the first task there? Least start, Abi. It says what? 3750 centimeter cube, Abi.
Yeah.
That was my V1, Abi. So what's the V1? 3 what? 75 what? Centimeter what? Cube, Abi.
Yeah.
What next then? P1 is what?
770
millimeter mercury. What next there? It says find the volume. That's what? V1 or V2. Is it V1 or V2?
V2.
Hold on, no. Hold on, no. It says that find the volume. I'm looking for V1 or V2. That's what? V2. So V2 is what there? On Abi. What next there? P2 is what? What's the P2? 750 Abi millimeter mercury. So of course, obviously, I'll still use what? This formula. This formula. This formula. So let's proceed, please.
V2 equals to P1 over P2.
So I'll still use that same what expression, Abi.
Yeah.
That V2 is what? P1, V1 over what? Are you sure?
Yes.
Over P2. So check there. What's your V2 is what's your P1? 770 times what of V1? 375 over what there? What's the P2? 750. What's my what's your V2? If I multiply this by this by 750, I should have 385 centimeter cube. So this is your answer. Let's look at Charles' law, please.
Procedures law.
Let's look at Charles' law and call today, please. So after boys look at Charles' law and call today, please. We'll call today. Don't state it, but don't record. All right, let's start with this. This states that the volume of a given mass of a gas. This says that the volume of a given mass of a gas. Are we there? Is directly proportional to its temperature, provided that the pressure is kept constant. Provided that the pressure is kept constant. Now here's the thing. For Boyle's law, temperature is what? Kept constant. And I'll use what? P1 V1 equal to what there? P2 V2 concept. For Charles' law there, what the pressure is now what? Kept what? Constant now in this case. That's like the two different things there. For Boyle's law, temperature is what? Kept constant. For Charles' law there, pressure is kept constant. Mathematically, are we there? From Charles' law, we say that the volume is what? Temperature to what? To what? Temperature. Right? I don't think of this sign.
Constant.
Equal to what? Constant. K, T equal to what? KT. Make K subject. K is what? V over T. This is what? Relationship between what? Charles' law. Abi?
Yeah.
Now at this point, note something please. At this point, note something please. Note at this point, please. Note. If pressure is kept constant, at this point, note something here. If pressure is kept constant, Charles' law can also be expressed as P1 over V1. What there? P2 over T1 over V1. What there? T2 over what? Over V2. I said if pressure is kept constant, it is V before T. Is V1 over T1. What there? V2 over what? Over T2, please. So if pressure is kept constant, Charles' law can also be expressed as what? V1 over T1. What there? V2 over T2. Are we there? So when it comes to Boyle's law, we said when we have volume, it can be expressed separately. Centimeter cube, decimeter cube, liter cube, milliliter, and liter. That's a separate unit for volume. For pressure, we said we have what there? Newton per meter squared. We have Pascal. We have a bar. We have ATM. Abi? We have mercury too. Newton mercury. Abi? For temperature, what are the separate units for temperature? For T, I have what? Degrees Celsius. Abi? We have Kelvin. I have what there? Fahrenheit. So these are the several units for temperature. Celsius, degrees Celsius, Kelvin, and what? Fahrenheit. So note that. So know something when it comes to Charles' law, always convert the temperature, please. Note, always convert the temperature when it comes to Charles' law. Please note.
No.
Note that when it comes to Charles' law, always what? Convert what? Temperature. If temperature is given in Celsius, convert to what? Kelvin. How? So note that Kelvin is equal to what there? Degrees Celsius plus what? 247 or 3 to 4. Yes, 273 per se. 273. So when it comes to converting Celsius to Kelvin, just add that Celsius value with what? 273. That's the concept. So let's say I'm given 15 degrees Celsius. Convert to Kelvin. What do you do there? Kelvin is equal to what there? That's 15 plus what? 273. What's Kelvin here? This should be equal to 15 plus what? 273. I have what? 288 what?
Kelvin.
Hold on, no. 288 what? Kelvin, Abi. So that's how you convert your degree Celsius to what? To Kelvin. So that's by the way. So let's look at example here. Just one example. And we'll put the day, please. One example under this. One example with the day. Are you there?
Yes.
At 17 degrees Celsius, put down. At 17 degrees, I said when it comes to Charles law, always convert your Celsius value to what? To Kelvin. So at 17, example 1, please. At 17 degrees Celsius, are you there? A sample of hydrogen gas. A sample of hydrogen gas, are you there? Occupies 125 centimeter cube. 125 centimeter cube. Are you there?
Yes.
What will the volume be at 100 degrees Celsius? What will the volume be at 100 degrees what?
Celsius.
If the pressure remains constant, please, for pressure to remain constant, is it Boyle's law, Charles law? Of course, Charles law. So first, write out what?
Our current.
So I'm given what? At 17 degrees Celsius. That's what? T1 Abi.
T1.
17 degree what?
Celsius.
You said convert to what? Kelvin. Now become what then? 17 plus 273. What do I have here? If I'm to have this, that's 290 what? Kelvin. Alright, it says again, a sample of hydrogen gas occupies what? 125 centimeter cube, Abi. That's V1. Abi? That's V1 is what?
V1.
125 what? Centimeter cube. Proceeding, he said, what is the volume? So now I'm looking for what there? V2. Right? Yes, V2 is fine. What is the volume? V2 is unknown. What next there? B at 10 degrees Celsius, Abi. That's T what? T2 is what? 100 degrees Celsius, Abi. Convert to Kelvin. That's 100 plus what? 273. That's what? 373 Kelvin. Are we there? So if pressure is kept constant, Abi, for pressure to be kept constant, or using what? Boyle's law. Sorry, Charles law, Abi. So recall from Charles law that
V1.
you said V1 over T1. What there? V2 over what? T2. Are we there?
Yes.
I'm looking for what? V2, Abi. Make V2 subject by what? Multiplying. V1 times T2 is what?
V1.
V1 T2 equal to what? This time this is what? T1 V what? Hold on. Yes, V2, Abi. Yes, V2. I'm looking for what? V2, Abi. Make V2 subject. Remember by what? T1. Remember by what? T1. This cancel this. What's V2? V2 is what? V1 T2 over what? T1. If I ask you, what's your V1? Check.
Everyone needs
125 times what's your T2?
our T2.
373 all over what there? T1. What's T1? 290. Are we there? V1 T1, yeah, 290. So my V2 now will be equal in value to 160.7 in what?
In
Volume.
What? Centimeter cube.
Centimeter cube. This is how you solve this particular. So next class, look at the ideal gas equations and etc. Next class. So do well to like the video, share to your friends and classmates so they can learn too. So welcome to Excellent Link Academy. See you in the next class.